Assalamualaikum and a very good day. My name is Fatin Hazirah. Today I will be presenting my final year project entitled Preventing Black Hole Attack in Mobile Ad Hoc Network using Improved Ad Hoc On-Demand Distance Vector Protocol. Throughout completing my research, I was supervised under Professor T.S. Dr. Muhammad Asri bin Ngadi. So these are the topics that will be discussed, and it is basically related to my thesis and will be explained by chapters for today's discussion. The first chapter is Introduction. This research focuses on three main components, which are black hole attack, MANET, and AODV routing protocol. Black hole attack is basically the problem that is existing in MANET when a malicious node pretends to have the shortest path from source to destination node. It will absorb all of the data packets that it receives, and this need to be solved using an enhancement of AODV routing protocol. The research aims to identify ways on how black hole attack can be prevented in MANET using the enhancements of AODV routing protocol. The research asks three main questions, which are: what are the findings of the existing methods? How can the enhancements of AODV protocol be designed? How is the efficiency of the enhanced AODV being evaluated? Then, the research objectives are to analyze the existing methods that prevent black hole attacks in MANET, to design enhancements of AODV routing protocol to prevent black hole attacks, and lastly, to evaluate the performance matrices of the enhanced AODV routing protocol. The scope of this research are network and security. MANET is the decentralized wireless network, and black hole attack is an attack that is existing in MANET, and how can it be prevented? Then, Chapter 2 will explain the literature review, which is basically related to the first objective of this research. First, I will explain the type of routing protocol in MANET and the research domain. In total, there are three types of routing protocol in MANET. The first one is proactive. Proactive routing protocols allow every node to have a clear and consistent view of the network topology by propagating periodic updates. All nodes are capable in making immediate decisions regarding the forwarding of a specific packet. The SDV and OLSR are examples of proactive routing protocol. Moving on to the reactive routing protocol, which is the domain of this research. A reactive routing protocol appears to be more suitable for ad hoc networks. It does not maintain an up-to-date information about the network topology, which means the information will keep on changing from time to time. The source node will start by broadcasting a RRAQ packet, and the intermediate nodes will reply with a RREP packet. Lastly is hybrid routing protocol, which combines proactive and reactive routing protocols to achieve a higher level of efficiency and scalability. ZRP is one of the examples of hybrid routing protocol. The research domain are AODV and black hole attacks. Black hole attacks is one of the most critical attacks on MANET, and it affects the whole network security. Obviously, a black hole attack impacts network layers, and it is considered as a DOS threat, which damages the transmission of the network layer. There are two categories of black hole attacks, which are simple and cooperative black hole attacks. Basically, simple black hole attack is easier to be prevented compared to cooperative black hole attack. Meanwhile, AODV is a type of routing protocol which performs route discovery using RREQ and RREP messages as mentioned earlier. The routes are set up by flooding the network with RREQ packets, which however does not collect the list of the transverse hops. This gives advantage to AODV, which is the routes are established on demand, and the distance sequence numbers are then used to find the latest route to the destination. Moving on to the third chapter, which is the research methodology. The figure displays the research framework, which is categorized in three different phases. The first phase is completed during final year project 1, which the concept and characteristic of black hole attacks are determined. Also, the AODV routing protocol is reviewed. And lastly, the solutions that are used which involve enhancements of AODV routing protocol in order to prevent black hole attack are observed. The second phase, which is developing and designing the experiment, took place at the beginning of final year project 2. The outcome of this phase are the system or the experiments are designed and developed using a tool named NS2. The system is also tested to provide better functionality. The last phase of the research is implementing, analyzing, and discussing the experiment. The experiment has been conducted and the findings of the experiments are discussed. This research contains three different experiments, which is standard AODV protocol, implementation of black hole attacks, and enhancements of AODV routing protocol. The comparisons between these three experiments are done and observed. The research focuses on two performance measurements, which are end-to-end delay and packet delivery ratio. Next, Chapter 4, which is the research design and implementation. In order to overcome black hole attacks, an enhancement of AODV routing protocol is introduced during the verification of RREP packets. This mechanism recognizes the node sequence number, index, routing table information before it can actually proceed to the default processes. As we can see from this figure, which is the flowchart of the enhanced AODV, initially a variable named verified is introduced and declared at the beginning for every RREP packet broadcasted in the network. Then, upon receiving RREP packets, the intermediate nodes will do some comparisons. If either this condition match, it will proceed to update the routing table and set the verified value to 1. After that, the RREP packets can be forwarded and continue default processes. Otherwise, if the conditions do not match, the RREP packet will be ignored immediately. In ensuring that all of the experiments can be conducted smoothly, a tool called Network Simulator 2 version 2.35 is used. Using TCL scripts, two different files is generated automatically, which are .tr and .num files. The .tr is actually the trace file, while the num is used for network animation. The tr files is very important to do the calculation of the performance matrices using AWK file method. These are the simulation parameters that are used for the three experiments. Then, Chapter 5 will analyze and discuss the results of the three experiments. The results are related to the three objectives mentioned in Chapter 1 earlier. The first objective, which is analyzing existing methods, which is used to prevent black hole attacks in MANET. A table of comparisons have been introduced to distinguish the author's name, method name, detection type, tool, and results. As we can see, most of the researchers prefer to use NS2 as the simulation tool, which explains why this research is conducted using NS2 as a simulation tool. All of the methods are used by enhancements of AODV routing protocol, which is suitable to detect multiple black holes the most. And most of the results are focusing on analyzing the packet delivery ratio. Then, the second objective, which is to design the enhancements of AODV protocol to prevent black hole attacks. The figure explains the pseudocode of the enhanced AODV, which is actually modified in the receive reply function by the intermediate and source node. Lastly, the third objective is evaluating the performance matrices of the enhanced AODV. These three tables distinguish three different experiments by the number of generated, received, and dropped packets, followed by the performance matrices, which are PDR and end-to-end delay. From this table, we can see that the enhanced AODV produces better value of end-to-end delay, especially for nodes for simulation with 30, 40, and 50 nodes compared to the experiments with standard AODV and the implementation of black hole attack. Also, the enhanced AODV generates and receives the highest number of packets at 50 nodes of network simulation. Since there is a presence of black hole node, the experiment with the implementation of black hole attacks drops all of the packets that are generated initially, which cause the PDR and end-to-end DA value to be 0. Based on these two graphs, it can be said that the enhanced AODV is actually safe to be used as a preventive method to stop black hole attacks from becoming a severe problem. The rate of the end-to-end delay plays a vital role in confirming that the solution actually works. Then, it can be concluded that the research has actually achieved three objectives mentioned in Chapter 1. Also, a new solution is proposed and is safe to be used as a preventive method to stop black hole attacks in MANET. Just like any other researchers, this research also has its own constraints. Firstly, setting the finest network topology is quite difficult. This is very important as the network topology, as the same network topology will be used for the three different experiments. Then, as a beginner like me, adapting to new tools like NS2 actually requires a longer time. However, it is actually better compared to other simulation tools which might cause longer time to be adapted. My suggestions for future researchers if they are about to continue my research is they can start to introduce a second RREP packet with the same variable name verified to secure the network topology more. Other than that, the experiments can be conducted with more performance matrices. Last but not least, the researchers can actually play around using different set of simulation parameters. I think that is all for today's presentation. Thank you for listening and have a good day.